Hello everyone. Today we are going to see a simple assembly scheme in assembler. Learning outcome. At the end of this session, students will be able to explain simple assembly scheme in assembler. Now first we see design specification for an assembler. Following 4 steps are we used to develop a design specification for an assembler. First step is identify the information that is required to perform a task. Second step is design a suitable data structure for recording the information. Third step is determine the processing required for obtaining and maintaining the information. And the fourth step is determine the processing that is required for performing the task by using the recorded information. So basically these are the 4 steps we use to develop the design specification for an assembler. Now here we see this is the design of data structure we used in the assembler, or also the phases of the assembler. So here there are 2 phases of the assembler are there, analysis phase and synthesis phase. And here 2 data structures are we used, symbol table and the mnemonic table. So here the source program is given as the input to the analysis phase. Here the source program is given to the analysis phase, then it given the synthesis phase. Synthesis phase generates the target program. Here during the analysis phase it generates the symbol table. So basically there are 2 fields are there in the symbol table, symbol and address. And here the another data structure is used in the design of the assembler is the mnemonic table. So there are 3 fields are there, mnemonic, opcode and length. So these are the 3 fields of the mnemonic table. So here the mnemonic table and the symbol table, these are the 2 data structures of the assembler, and the analysis phase and synthesis phase, these are the 2 phases of an assembler. So for here the input given is the source program to the analysis phase, and synthesis phase generate the target program. Now we see the analysis phase first. Basically the analysis phase, the primary function that is performed by the analysis phase is building the symbol table. So here it builds the symbol table. So for this purpose it is required to determine the address with which the symbolic names that are used in the program are associated. So here for building the symbol table, it requires the addresses with the symbolic name that is used in the program are associated. So it is possible to determine some addresses directly, for example address of the first instruction in the program, but others must be inferred. So consider the assembly program of figure to determine the address of n. So in that case here it is required we must fix the addresses of all the program elements that is preceding it. So this function is called as a memory allocation. So for allocating the memory, here to implement the memory allocation, a data structure called as a location counter it is used. So here the location counter it is always made to contain the address of the next memory word in the target program. And here the location counter it is initialized to the constant that is specified in the start statement. So here the LC it is containing the address, the constant that is specified after the start statement. Whenever the analysis phase sees a label in the assembly statement, it enters that label and the content of the corresponding location counter as a new entry of the symbol table. After entering that label in the symbol table, it then finds the number of memory words that is required by the assembly statement, and according to that it updates the location counter content. To update the content of the location counter, analysis phase needs to know the length of the different instruction, and the processing involved in maintaining the location counter it is called as a LC processing. Now next we see what are the tasks involved in the analysis phase, the task of the analysis phase. Now consider this example 1 mult b register comma a. So here first of all the analysis phase separate out the content of label, mnemonic subcode and the operand field of a statement. So here in the given statement 1 is the label, mult is the mnemonic opcode and b register comma a, these are the operands. These are the 2 operands are used in the instruction. So the second task that is performed by the analysis phase is what? If there is a label is present, then it enters that label into the symbol table. So how we enter that label in the symbol table? In the symbol and the corresponding location counter content. There are two fields are there in the symbol table, and it enters that symbol and the corresponding location counter content as a new entry in the symbol table. So here one is the label, it is founding, here one is the label. So here the one label is it is entered into symbol table. So the label name is 1 and the address corresponding location counter content, the location counter will be address is 100. Now the third task that is performed by the analysis phase is the check the validity of the mnemonic subcode through the lookup in the mnemonic table. So here the mnemonic table is there. So in that mnemonic table we see the upcode, mnemonic upcode, to verify the validity of that, upcode. And the fourth task that is performed by the analysis phase is the performing the LC processing. That is nothing but it updates the value that is contained in the location counter by considering the upcode and the operands of the statement. So basically the analysis phase performs the 4 different tasks. Now after seeing the analysis phase, can you tell me, to implement the memory allocation, a data structure called dash is used in analysis phase of an assembly language? The options are, first option is the instruction counter, second option is the location counter, third one is the DS, and the fourth one is the DC. Pause the video and think on it. To implement the memory allocation, a data structure called as a location counter, it is used in the analysis phase. Now the next phase of the assembler is the synthesize phase. So here consider the following assembly statement: move R B register, 1. So here when we in the synthesize phase it generate the target code. So here it requires the following information to synthesize the machine instruction corresponding to the above statement. So first it requires the address of the memory word with which the name 1 is associated. And the second, it requires the machine operation code of the mover. So the first kind of the information, that is address of the memory word with which the name 1 is associated, this information depends on the source program and it must be available by the analysis phase. So here the address of the memory word with which 1 is associated, the address it is available in the analysis phase. And the second information is required is the machine operation code of the mover. It does not depends on the source program, so it depends on the assembly language. So hence the synthesize phase can determine this information. So basically for the synthesizing the machine instruction for corresponding the statement, we require the address of the memory word with which the respective symbolic name is associated, and also we require the machine operation code of the respective mnemonic. Now we see the task of the synthesize phase. So first task of the synthesize phase is obtain the machine opcode corresponding to the mnemonic from the mnemonic table. So here we say how we convert the assembly language to the machine language. The statement is move R B register, 1. So here we obtain the mnemonic numeric opcode for the move R. So here we see this is the table. So in that table we see what is the numeric opcode for the corresponding mnemonic mover. So the opcode is 04. So here we obtain that machine opcode for the corresponding mnemonic from the mnemonic table. So for the mover the opcode is 04. So here we specify the opcode is 04. So here in the field we specify 04 is the first task. The second task also we require the here also we require the code for the B register. So the code for the B register is 2. So it is also we obtain from the table. So the code for the register B is the 2. So we specify the 2. And the next we obtain the address of the memory operand from the symbol table, because here the 1 is the second operand is the 1. So 1 is the symbolic name. So that symbolic name we already entered in the symbol table. We obtain that memory address of that symbol from the symbol table. So assume that consider the address of the 1 symbolic is the 100. We specify the 100. And the third step, we synthesize the machine instruction, means what? Here we convert from assembly language to the machine language. So in this way the synthesize phase generate the target code for the corresponding assembly statement. These are the references. Thank you.